A video camera is 3 feet tall and is positioned 50 feet away from a mountain that a mountain climber is scaling. The distance between the camera and the climber can be represented by the following equation. So as I'm scanning through the questions, we're all going to have an output of a distance between the camera and the climber, and we're all provided with an input that's in terms of degrees. So let me transfer right now. I just want to write down each of these degrees. 0, 26, 52, 90, and then 52 again. And this gives us this distance that is the hypotenuse. So our output value is that hypotenuse. Okay. One second here, because this will lead up to part E. All right, let me switch now. So I'm going to come back here to camera, and I have started my calculator over. I am going to go into mode, and I'm going to automatically switch it to degrees. And then I'm going to come up to the very top, and I have to remember, what was that equation? It was 50 secant of theta. So 50, now instead of doing secant, secant is the reciprocal of cosine. So I'm going to take 50 divided by the cosine, and we don't have theta, we do use x for our input. All right, so these are going to be our input values, and our output will be the distance from the camera to the climber. We can see the distance horizontally is 50. So let's go out quite a ways here. Let's go out, so these are going to be the values that I plug in. Let's go out to at least 100, and then we'll do zoom fit. Okay, when this angle is 0 degrees, second trace value, the distance from the camera to the climber is 50. I believe it was in terms of the units was feet. I'll check when I'm done, but I believe it was in terms of feet. Second trace value, let's check when it is at an angle of 26 degrees. The distance would be 55.63. Okay, when it's at 52, the distance would be 81.23. When we go to 90 degrees, so the distance is 90, when you don't have an answer, it represents infinity. Now, if I come back here and read part E, it says find the height of the climber. So I need to go back. This is the height. I want to know this distance here from the ground up to where this climber is. I know this horizontal distance is 50, and they're providing us an interior angle of 52. So I'm going to go back again and figure out what is the distance from the camera to the climber. It's 81.213462. Now I can use Pythagorean theorem to figure out this leg, knowing that this is a right triangle. So a squared plus b squared equals c squared. It doesn't matter if 50 goes in for a or in for b. Ultimately, I'm plugging this in for c and squaring it. I'm going to plug in 50 for b and squaring it. I'll isolate the a. So right now I'm going to take c squared, and I'm going to subtract, when it moves to the right-hand side, I'm going to subtract 50 squared. So 81.213462 squared, subtract 50 squared. That's on the right-hand side. Now I need to take the square root of it. Normally we would say there's two answers if we were doing this algebraically. We know this is distance, and distance is always positive. So square root, let's copy in that previous answer, and we can say the height of the climber to the ground is approximately 63.997 feet above ground. Let's read this problem. An airplane flying at an altitude of 30,000 feet. Its distance from a 50-foot tall observation tower can be expressed by the following equation. And then we want to find that distance given a degree. So I want to make sure that my calculator remains in degrees. I'm going to plug in the following equation. And when I look at these 4 different input values, again, they're all in degrees. 2 of them stand out as some of those common angles. Common angles would be like your 0, 30, 60, 90, and so on, or 45, 90, 135, 180. So your 45s and your 30s, and I can even algebraically do those two. Let me show you. So let me come back here and just demonstrate here. These two I can just do by hand. So where is 90 degrees? 90 degrees on the unit circle is right here. And 90 degrees has a cosine like an x value of 0. And for the ordered pair, the y value is 1. Doesn't go left or right, it just goes up 1. This is the cosine, this is the sine. Now, if I was going to express tangent as a ratio, it would be 1 over 0 because sine over cosine represents the tangent. But I'm asked to evaluate the cotangent, which is 0 over 1. So when I substituted 90 for cotangent, I receive 0 over 1. Well, 0 over 1 is simply 0. 0 divided by anything is 0. So this portion evaluated at 90 degrees is 0. 0 times any number is 0. Let's come down and do 0. So at 0, which is, draw another circle, it is right here. We have an ordered pair of 1, 0. Again, if I'm going to evaluate a tangent, this is cosine, this is sine. Tangent is cosine or sine over cosine, sine over cosine. But when we evaluate cotangent, we're just going to take the reciprocal of that. It's 1 over 0. So I would take 1 over 0 times this value. But 1 over 0, you can never have 0 on the bottom. It's undefined, and we represent undefined, in this case, with infinity. So this would be the answer for part A and part B. Now, I went ahead and let me turn on my calculator, make sure I was in degrees. I plug this in. So this is 1 over tangent, or 29, 29,950. As long as tangent's on the bottom, it will represent the cotangent. So I graphed it. I made sure that my input values went a little bit past 90. In fact, I went out to 100, and then I did zoom fit. Now I've already taken care of A and D. Let's do B. So for B, I'm going to do second trace value, and 82 is going to match up with approximately 4,209.198 feet. That's the distance from this observation tower to the airplane when this interior angle is 82 degrees. Now let's do 20. Interior angle is 20. Now the distance is 82,286 feet, 0.949. The average daily temperature T in degrees Fahrenheit for a certain city is given by the following function, where T is the time in days and T begins with January 1st. So when T equals 1, we're on January 1st. Find the average daily temperature of the following days. How we plug this in really matters. How we plug... Yes, you can, Benny. Sorry, he's doing his timed reading for the day. How we plug this in really matters. So let me bring this back to this paper, and let me clear my calculator. All right, now I'm going to have to switch back and forth here. Okay, so we have 45 minus 23. All right, 45 minus 23. And I'm just going to take a second here to write this down to ensure I don't make any mistakes. So I have 2 pi over 365 times t minus 32, times 32. Okay, so notice there's more than one item on top. Anytime we have more than one item on top, we're going to put an extra parenthesis around it. Okay, so I have 23 cosine. Now I'm going to do a couple parentheses here. So I have this initial parenthesis, and then I'm going to do an additional parenthesis for 2 pi, and why? Because there's more than one item, so it's going to be hugged together within parentheses. Oh, I want to add an extra parenthesis there to represent just this fraction. So here's 2 pi hugged divided by 365. So this in parenthesis here is around the 2 pi, and then this second parenthesis begins this fraction. This last one ends it. So there's 2 here and 2 here. That's this portion. This first parenthesis represents what you see as brackets. Now we have that times x minus 32. And now we're going to go to window. We're talking about an entire year, so I'm going to go 0 to 365. I want to make sure my mode is in radians, and let's graph this. Oh, I should have hit zoom fit, and I think I previously did that, but let's just make sure that's the case. So as soon as it gets done here, I am going to hit zoom fit one more time. Zoom fit. And while this is graphing, I want to find January 1st. Well, I know January 1st is t equals 1. I want to find July 4th. I know that's t equals 185. I want to find October 18th. That's 291. And then I want to find the period and what does it represent. Okay, so let's come back to this graph. And we have January 1st, so second trace value. I'm inputting the day of the year. So approximately 25.2 degrees Fahrenheit would be this average. And I want to go back really quick. I think it's average high. No, it's just average daily temperature. It's average daily temperature. Let's go to July 4th. July 4th here would be day 81, 85. So the average daily temperature on July 4th for this town would be 65.1 degree Fahrenheit. On October 18th, the average temperature would be 50.8 degrees Fahrenheit. And then the question is, what is the period for this and what does it represent? So the period for this is the length of a year, 365 days. Now, how could we find that algebraically? 2 pi, I'm going to divide by whatever's in front of the x. So I want to take 2 pi and divide by this amount because it's in front of the x, or in this case, t. Now, when we divide fractions, we're going to multiply by the reciprocal. And that's how we end up with 365, which represents. Okay, let's look at number 15. Number 16. Number 16, a company that sells seasonal products forecast monthly sales over a 2-year period represented by the following equation, where S represents is measured in thousands of units and T is time in months. T equals 1 represents January 1st. Estimate the sales for the following. All right, and the very last thing is find the period. All right, so let's come back down here. I wrote this down. So January 2000 represents month 1. It's T equals 1. And we're going in months here, so this would be 1 month later. When I plug this in for the input, this would be T equals 2. Now, this isn't a whole an additional year, so I'm going to do 12 plus 2. This would be T equals 14. Now, we have January, February, March, April, May, June, July, August, September. So this is month 9 of the first year of this. So X equals 9. Now this is 1 year past. So this is another year plus that 9 to give us T equals 21. So I'm going to grab the calculator and I plugged in exactly what was provided to us in this equation. And you can see that here. Now, I tried to figure out what should be my window. So I know 2000, I went all the way out to 2001. So I decided to go for 2 years. 2 years would be 24 months, and then I'm going to do zoom fit. Okay, let's check this out. All right, so remember it needs to be in thousands. It needs to be in thousands. I'm going to come back really quick to read this. We see S is measured in thousands of units, and we want to estimate the sales. So it's within thousands. We need to take wherever the decimal is and move it 3 places to the right when we come up with our outputs. Let's start with the first one. Second trace, the value, plugging in 2. So in February 2000, we can say 27,708 if I round it. So this again would be 27,000 and this would be 708. I want to read that one more time. This is in sales. This is sales. Okay. Let's look at the next one. So now I'm going to go up to 14. And at 14, if I zoom in here, it appears to be 33,000. So it looks like it's 33,012 if I round it to the nearest unit. Let's go for September 2000. September 2000 is going to be a 9, and that's going to be 22,778. Again, that decimal gets moved 3 places to the right because it says in thousands. And my last one is September 2001, and that's going to be T equals 21 for 28,082. So these are my markers. And then we're asked to figure out what is the period. So let me come back here and look what's directly in front of the x, or in this case it's t, would be pi over 6, coming back to my thing. So this is a sine curve. I'm going to take 2 pi and divide it by this quantity, which is like multiplying by the reciprocal. Our pi symbols are going to be reduced down to 1, and we end up with an answer of 12. So 12 months or 1 calendar year represents the period for this function. The monthly average high temperature in Phoenix, Arizona during the year 2006 is provided in the table below. Use the regression capabilities on your graphing calculator to create a trigonometric model of the data. Let t equals 1 represent January 2006. So we have all the questions here, and I wrote down these questions that you saw as you're watching before I flipped over. So these are all my questions. Again, it says January. I just want to make sure that's correct. January 2006 is going to be t equals 1. Okay, January 2006 is t equals 1. All right, so how do we go about plugging this in? So I'm going to do second plus 7, 1, 2 to start here. Put this in an area that doesn't have as much glare. Okay, and so I'm going to go up to stat and edit, and 1 through 12 will be the month. So the January will be month 1, February month 2, March month 3, and so on. So 1 full calendar cycle will give us 12 months, and then I'm going to put these average temperatures in. I'm going to go back here as average monthly temperature. Okay, so we had in there, let me actually flip back here and type these in: 66, 70, 75, 84, 93, 103, oops, I put 703, 103, 105, okay, it looks like I've messed up somewhere. Let me go back and find out. So I have 66, 70, 75, 84, 93, 103, 105, 103, 99, 88, 75, and 66. So it must be, I see where I messed up. It was the months. I forgot month 5 when plugging them in. So I'll come back here. I found my mistake here. 7, 8, 9, 10, 11, and 12. All right, they're all in. So we're going to go stat, calculate, and go down here. Now, I wrote down the question, so I know that one of the questions talks about what is the period. And period we can, since this is a sine function, we can take 2 pi and divide it by the value in front of the x, which is this value. So I'm just going to write this down at this time. So I have, if I move this down, I can zoom out here so you can see. I'm just going to write this down. The value in front of the x here is 0.5312941481. That's going to come into play when I do step 4. Okay, now let's take this and copy it and paste it in here. Vars, stat, EQ, and now let's look here. We know this is the year 2006, but I have questions about 2007 and 2008. So when I go to Windows, I don't want to just go out for 1 year, which would be 0 to 12. I want to go out to at least through 3 years. So through 12 would be 2 years, through 24 would be 2 years, sorry, through 12 would be 1 year, through 24 months, 2 years, and through 36 would be through 3 years. So 36, now zoom fit. Let's take a look, see if we can see a cyclic pattern. A pattern that seems to cycle over. So this looks like year 1, year 2, and year 3. All right. So let's figure this out. July 2007. So I have 1 full year because 2006 is already done. So I'm going to go second traits. I have 1 full year or 12 months because we're inputting them in as months. That's for the year 2006 since that's what we're starting. Now I know because July is my birthday that July is month number. Anybody know? Anybody know? Month 7. Month 7. 1, 2, 3, 4, 5, 6, 7. So 12 plus 7 or 19. And we can see in the month of July 2007 that the average temperature is 105.88 degrees Fahrenheit. Now let's calculate March 2008. So again, let's go second trace value. So we're in 2008. So there's for 2006 when we started this, 2007. Now 2008, 8 is March number. March is month number 3. So I could have put down 27, or you can see the breakdown of how I did it. And we have an average temperature March 2008 as 77.47 degrees Fahrenheit. When can we estimate that it will surpass 100 degrees for the first time? So in which month? In 2008. So this is 2006 when it starts, 2007 and 2008. So I want to look at this last cycle. When does it surpass 100? Well, let's see when it equals 100. I'll go up to y equals, typing in 100 and graph it. I want to know this measurement. When does it first hit? So second trace intersect. And I'm going to trace all the way over to that portion. Enter, enter, enter. And we can see that it equals 100 for the first time in month 29. Well, what does 29 even mean? So 29, well, let's break it into groups of 24. So this is month or year number 1, so year 2006, year 2007, so we're up to 24 months, and we have to go up to 29, so that's an additional 5 months. Month 5 is 1, 2, 3, 4, 5. That gives us May 2008. During that month, it will hit it, and then it will surpass it going past that point. So what is the period? Since this is a sine curve, we're going to take 2 pi divided by this amount that I was able to take when we did the stat calculate. Just demonstrating again where I found that. And it's the value in front of the x. Give it a second. So in front of the x, it's this value. So I'm going to take 2 pi, get a decimal answer, and then divide it by 0.5312941481. So 11.8 approximately is the period. Now, in a perfect period, if this was done perfectly, it would be 12 months, exactly 12. An apartment complex is a heated pool that can be used year-round. On the first of each month, the number of people that use a pool is recorded. So just so we can see, this is January 1st, so that would represent an input value of 1. This is February 1st, there's 32 people that use the pool. That'd be input value of 32. Like for instance, July 1st, we represented by an input value of 182 and so on. Okay, so we want to go ahead and use our graphing calculator, and then we want to figure out what is April 15th, what is July 4th of this year, and then we want to do the following year on July 4th. Okay, and the following year on July 4th of the next year. Okay, I want to first figure out if we want to do April 15th. So if this is April 1st, so April 1st, I'm going to write this down. April 1st is 213. And if we want to do July, oh, sorry, that's not April, that's August. April 1st is 91. And July 1st is 182. Okay, let me come back now. So this is July 1st. So how many more days to hit? Well, let's first go through here. I went through and I entered everything in. Days is going to be, so the day represented with the number of people that are in the pool. This is the first day of each month in order. And then I'm going to hit stat, calculate, go all the way down as we have been doing to option C, enter it through. And then I copied and pasted in here already. Now, I know that 365 days is 1 year, but I want to go at least 2 years because it's asking about the following year. So I went up here and I took 365 plus 365 so I can go out as far as input values of 2 years. And then I did a zoom fit. Our output will tell us a prediction of how many people are using the pool, and we'll round to the nearest whole number. Okay, second trace value. So we want to do April 1st or April 15th. Well, April 1st had 91, and then we have to ask ourselves how many more days until April 15th. That'd be 14 additional days. So this represents the number of days, and so we have 105 days, and that has an output value of approximately 119 people using the pool at this apartment complex. Let's do July 4th of this first year. Second trace, we know July 1st is day 182. how many more days until we hit July 4th? That's 3 additional days. And we can estimate approximately 210 people would be using the pool. Now the following July 4th, the following July 4th would be, we know it's already 1 calendar year past. Then just to get to July 1st is 182, plus that 3 additional days to go from July 1st to July 4th. And we have approximately 209 individuals at this apartment would use the pool the second July 4th.